Now, this is a different form of the quadratic that could be obtained from this one, okay? But this is the form that works with the quadratic formula, okay? If I knew what A was and H and K, I could just evaluate, you know, T minus H squared, multiply that by A, and then add K, and I'd have this, okay? And if you don't understand that or don't see it, don't worry about it. Let's focus on what this is telling us, okay? I'm telling you then that if I have it in this form, then it's going to be equal to 0 for the values of t that you get from the quadratic formula, right? Okay. Now, of course, if your curve is here, your value, y value is never 0, right? But in general, it could be. Like if you lower this curve, then it's going to have some zeros, okay? If there are zeros, negative b over 2a is going to be halfway between them. Because where do you see negative b over 2a in here? Just get rid of that plus or minus and you got negative b over 2a, right? Okay? Okay, so here's a parabola. Okay, so the zeros are here and here, where the graph crosses the axis. What's halfway between the zeros? Okay, this point is halfway between the zeros, right? And if I draw a vertical line through this point, it takes me to what point? This point here. How would you describe this point on a parabola? There's a name for it.
The origin.
Well, the origin's the origin of the origin's over here, but it corresponds to the point on the where the basic function's at the origin, right? Okay. Anybody know what's unique about this point of the parabola? And what's unique about this line? Well, this line being halfway between the zeros and the parabola being the same on this side as it is on this side of a line through that point. this is kind of right in the middle of the parabola, such that this side reflected gives you this side. Does that make sense? So this is called your axis of symmetry, and this point is called the vertex. Okay, there's a vertex. Now, hopefully you understand a little bit about why that has to be the axis of symmetry, because the parabola is symmetric, and because negative b is halfway between negative b plus this and negative b minus this. You might not totally understand that phrase, but you need to lock in the axis of symmetry is that, and I put a box around something I shouldn't have, so see if I can fix that. The axis of symmetry is where x equals negative b over 2a. It's equidistant from the two zeros. It's the perpendicular bisector of the line that connects the two zeros. But nobody learns much geometry, so you might not understand that statement, okay? So we won't worry too much about geometrical language, but in case you understand it, that's a kind of a good descriptive statement. But some people, you know, have had good geometry courses. And some had good geometry courses a long time ago and don't remember that, but no big deal. Okay. What I want you to understand from what I've done here, and then you'll see how it applies in the question I'm going to ask you. We can transform this basic t-squared function by moving it over, flattening it, or maybe stretching it. You know, squash it down this way or stretch it out this way. And then either raising or lowering it. Okay? To fit any function of this form. Any at squared plus bt plus c function, any quadratic function. The axis of symmetry is how far you have to shift it over. Okay? That's where x equals negative b over 2a. You go from the x equals 0 over here to the axis of symmetry, and that tells you where your low point on the graph is. Or if it's an upside down parabola, the high point. The idea is there are three transformations we can use to do this. Horizontally shift it, vertically stretch it or compress it, and raise or lower it. Okay? Those three operations on the basic functions, along with composites of what we can get from those things, give us almost every function we need to do almost anything. Unless we're research physicists or engineers or something. Okay? But it's a good basis for them too. So if you're going to be an engineer, it's a good start. I want you to have that picture. We can transform these things three ways and get a huge variety of functions that have a lot of meaning, and one of them is going to model what happens with this bottle. And then the one thing I want you to know, well, I want you to know the quadratic formula, and I want you to know how to isolate that axis of symmetry. Okay? And we'll build on that probably through next week. And you'll have some problems that ask you to work some stuff out. Okay? Okay, good.